Hi ladies and gentlemen, this is Mr. Green and this is another in my series of videos dealing with today the sum of the angles in a polygon. And I've got a guest speaker that I'm going to let speak for me today because I think this person does such a good job of describing about the angle sum theorem and then some other problems after that. So let's listen to him.
Hey, now I want to share with you one of my favorite geometric theorems. It's really, really cool. It's called the polygon angle sum theorem. And it says that the sum of the interior angle measures of a convex, that means no indentations, polygon with n sides is given by n minus 2 all times 180 degrees. And this is so cool because it seems like, how can that possibly be true? Just no matter what the number of sides are, as long as we know the thing is convex. Like here's a crazy thing. How many sides does it have? 1, 2, 3, 4, 5, 6, 7. Septagon. So now, how do I know how many angles there are, the sum of the interior angles? Now, where are the interior angles? The interior angles, of course, are the ones on the inside. So it's this, and then this one, and then this one here, and this one here, and this one here, this one way over here, and they might all be different. But if you take the measure of each of those and add them all together, it turns out that no matter how you draw this, if it has 7 sides, it's always going to have the same sum of angles, namely 7 minus 2, which is 5, so 5 times 180 degrees. Now, why is that true? Well, let me show you the idea because it's so cool. It just involves triangles. Now, remember that the total sum of the measures of the interior angles of a triangle is 180 degrees. If we remember that, then we're home free, because look what I can do. I can take this picture and cut it up into a bunch of triangles. And how many triangles do I have? 1, 2, 3, 4, 5. And notice 5 is 2 less than 7, the number of sides I have. Well, if each of the angles in each triangle, the sum of those angles is 180 degrees, then what's the total sum measure of all the angles? It'll be 180 plus 180 plus 180 plus 180 plus 180, which is 5 times 180, which is exactly what the theorem asserts. That's actually the idea, the proof of the theorem. It's really that easy. It just hinges on the fact that we know the sum of the angles of triangles. So that's really, really cool. Now, let's look at an example. Suppose I look at a hexagon. So a hexagon, we know, has 6 sides. So if I draw one, 6 sides. Not making it regular, but I am making it convex. And now I want to know the sum of the angles. No matter how I've drawn it, what's the answer going to be? Well, I see that I have 6 sides, and so I have 6 minus 2 times 180 degrees. And what does that equal? Well, that equals 4 times 180 degrees, which equals 720 degrees. So the total sum of all those angles is 720 degrees. Really, really, really cool. So let's take a look at some examples together and see this happening live. So let's find the sum of the interior angle measures of a convex hexagon. Well, that's what we just did, in fact. So you already know the answer to that. That's 720 degrees. So that's pretty good. How about this one? Find the measure of each interior angle of a regular octagon. Okay, now this is a different question. You see, what makes it different? Each. The theorem tells us about the sum of all of them, and now I want to know the measure of a particular one. But I am actually happily and luckily given one extra piece of information. It's regular. Remember what regular means? It means that all the angle measures are the same on the interior angles, and all the sides have the same length. So in fact, this is a very, very, very special octagon. It's not just, in fact, you know what kind of octagon it is? It's the kind that we see in red usually, which I'm going to try to draw live. This is always not good, by the way. All right, here I go. A stop sign. How can I not draw a stop sign? There we go. That's not perfectly right, but you get the idea. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, and all the angles are the same. Hey, if all the angles are the same, then I know if I can find the sum of all of the angles, all I have to do is divide by the total number of angles I have, which are, of course, 8. So I'll use the theorem to find the total sum of the angles, and then since I know all the angles are equal, I'll just take that answer and divide by 8. So what do? If we work this through, what I see here is I use the theorem. I have 8 sides. I subtract 2, and I have 180 degrees as a multiple here. And so I see 6 times 180 degrees. And now, to actually get the answer that we want, that's the total sum, I have to divide this by 8. So if I divide by 8, that's going to tell me what each individual angle is. And so now let's see if we can now simplify a little bit. And so if we simplify this, we get down to just 3 times 45 degrees, which equals 135 degrees. So that means that each angle here, right here, has a measure 135 degrees. Really neat. So notice how we went in a regular polygon, we went from knowing the sum of all the angles to actually knowing the measure of one angle by dividing by the number of sides, which is the same as the number of angles. Really cool. All right, let's take a look at an even more exotic example. This one has a little bit more of an algebraic flair. And so now here is the question. The question is, I'm given this quadrilateral, okay? So it's PQRS. And what I want us to figure out is the measure of all the different angles, knowing that, in fact, this is called x, and this has the same measure, x, and this has a measure of 4x, and this has the same measure, 4x. How could I possibly do that? All those x's are running around in our heads. But relax, because we know what the sum of all those angles is by this wonderful theorem. How many sides do we have here? 1, 2, 3, 4. It's a quadrilateral. And so I know I've got 4 sides, and so what does that mean? It means that I can figure out the sum of all the angles. Well, the sum of all the angles would be 4 minus 2, which would be 2. 2 times 180 is 360. So in fact, the sum of all the measures is 360. But I know each individual measure, and I can add them up. It's x plus 4x, that's 5x, plus x is 6x, plus 4x is 10x. And I can now solve this equation for x by dividing both sides by 10 to isolate the x. And if I do that, I see that x equals 36. So this is 36 degrees. And this is 36 degrees. But what's this? Well, this is 4 times 36, which is 144 degrees. And this is 144 degrees. So we were able to even figure out individual angles for polygons, even when, in fact, they're not regular, as long as we know some relationship among the angles. In this case, how the angles are related by this x, x, 4x, and 4x. Very cool. Very, very cool. Great theorem.
Professor Borger is going to continue here with one more example, so don't give up.
All right, but now I want to show you a theorem that's even, well, as cool as the last one. Now let's look at exterior angles. So here's the polygon exterior angle sum theorem. It's sort of a mouthful, but the theorem itself is really cool. It's that the sum of the exterior angle measures one angle at each vertex of a convex polygon is 360 degrees. A lot of words there. What's going on? Let me just draw a convex polygon. Doesn't have to be regular, so the sides can have different lengths. There's one. Now, if we extend the sides a little bit, so we stick some wood at the end. Oops, around a little space there. Then you see that we have these exterior angles. They're the angles that are out here. And so this theorem is talking about what happens if you add up all those exterior angles. It turns out no matter how I draw my convex polygon, no matter how many sides it has, it turns out that the sum of these angles is always 360 degrees. Always. And really, that follows just from the previous theorem, which tells me what the sum of the interior angles are. And we know that for each interior angle, I've got the interior angle and the exterior angle, and they add up to 180. And so I've got 180 here, and 180 here, and 180 here, and 180 here. So how many 180s? Oh, wait. Yeah, how many 180s is that? Well, that's going to be, oh, I forgot something here. See? I really should have something here. Whoops. There we go. Did you miss that? Did you miss this little teeny thing here? Don't forget that. That's important. I like that. Okay, so now when you add these things up, what you get is 360 degrees. And that really follows, it connects nicely with this theorem right here. So let's take a look at an example. Let's take a look at a regular hexagon. And I want us to find the measure of each exterior angle. Now again, here's the word each, and we only know the sum. But what's the problem? The problem is that since we know that it's regular, then I know that every exterior angle will be equal. And so what do I see? Well, a hexagon has 6 sides. And so what's the sum of all the exterior angles? The sum of all the exterior angles we know by this theorem is 360 degrees. And so what is the measure of 1? Well, since they're all the same and there's 6 of them, I take 360 and divide it by 6, and I see 60 degrees. And so in fact, we see that the measure of each exterior angle of a regular hexagon is 60 degrees. And you can see the power of actually using regularity. Let's take a look at one last example here. So here's a figure where you can see all the exterior angles are marked. And again, it's not a regular figure at all. I've got this quadrilateral, STUR. But you can see that I'm given a relationship between the exterior angles. This is x, has a measure of x degrees. This is x. This is 5x. This is 3x. And the question here is to find x. Find x. That is our mission usually in mathematical life, is to find x. Well, we know what the sum has to equal. The sum has to equal 360 degrees. That's the sum of all those exterior angles. But we can actually add them up. This is x plus x, that's 2x, plus 3x is 5x, plus 5x is 10x. So I know that that's the sum. And so if I divide both sides by 10, I see that 36 equals x. And that's what I was asked to do, find x. So you can see that this theorem allows us to actually solve interesting geometrical questions where it's not clear we could even do it. It's like, wow, how would we possibly figure out the value for x? The answer is that we know the sum of all of those angles. It's 360 by this great theorem. And so now I can just solve for x and actually figure out x exactly. Anyway, it's really neat to see the angles coming together for polygons in a wonderful way, and we get these two wonderful theorems that talk about the sum of angles. I'll see you soon.
And I appreciate you listening to our guest speaker here. I want to remind you all that if you're sending me any questions or sending me information, always include the name of your course that you're in, which is geometry, and what section you're in. It helps me find you, and it helps me get information back to you as quickly as possible. I'll look for you next time that we're together. Bye.